Welcome back to our next installment of the Mech suit evolution. So this time we've made some changes. So we've mounted the arm to this lally column here to make it a little bit easier to support. You can see our cylinder and the arm, and we're just using so this is pretty much oriented the way a human arm would be. This is a bicep joint here. It's pretty rigid right now. It's pressurized at 40 psi, and we've mounted the valves on a piece of wood, and we got the second regulator valve, so we have regulated pressure on both the inlet and the outlet ports, and a valve for the inlet, outlet, and then I'm funneling both to the exhaust so we get some speed control, which we'll talk about that another day. So now, compared to last time, the last experiment we did, we showed that we could use a 555 timer to send a pulse stream to these valves and get some control, so it wasn't just slamming the valve on or off. So if I just actuate this manually, it pretty much goes pretty fast. I do have some exhaust mufflers on, so it slows it down a little bit. But we want a little bit more fine control if we want to actually make this computer controlled. So we've now hooked it up to a computer and wrote a command line program so we can send pulse streams in a controlled way, and just a command line program just so I can experiment with different pulse widths and patterns. We're going through a USB port to this Arduino microcontroller. This is an Arduino UNO, which has just got an Atmega chip on there, which is really easy to program and just interface to, so just don't have to worry about putting a whole bunch of stuff together. Everything's there, some I/O pins, digital and analog. And so the only thing external here is I've got a couple of MOSFETs to control the 12 volts DC going to each of the valves. So I'll do a quick test here. Just press one command there. I'm not sure if you can see, but I get LEDs to show the firing, which is what I'm sending in. And then on the right side you see the LED, which is actually the kickback from when the coil discharges. That's actually not powered, that's just the discharge of the coil when you turn it off. So let's see if I can arrange this. So I got valve 1 configured to go in one direction with a very smooth, very small pulses. If I do a display, I'll tell you what I got. So it's 10 pulses for 5 milliseconds on and 10 milliseconds off. And we'll see what that looks like. The only problem with this is sometimes it gets stuck because there's really not much force there. So you can see again, very fine control of that. Each time I press enter here, I'm getting another short pulse burst. The other one I have at valve 2 at 10 pulses, 20 milliseconds on, 20 milliseconds off. And so you can see that one goes a little bit harder. And let's do this. Let's send that down, do valve 2 again. So clear, I can get some different speeds. So now that we've got this, one of the things I have to worry about is it's not linear. Depending on the position, it needs a little bit of force to break the static friction. But once you get going, you can see I get some very fine control now. You can move it just as very, an inch. Let's see how much. Yeah, it's about an inch a time. So with that, we can now write some programs to control this in a more directed manner, get some feedback in there. But we've got the whole configuration now that we've got the microcontroller, a C program that can drive it, valves to move it in both directions. So I think we're good to go. We've got to do a few more changes to make this a little bit more controllable, but then we'll be able to make this do some real work now. And that's it for today.